Very good. That is really dog and bugs. Genius.
G'day, you're right. Welcome back to a brand new topic on the Mathematics channel. Today, our new topic we are starting is called circles. Our first lesson in this topic is called circumference. Alright, so before we talk about what circumference is, we need to look at different parts of a circle or circular shapes that have specific names that we're going to be using throughout this topic. So we're starting off with some terminology. Alright, so parts of a circle. Here is our circle. To start off, we have a dot at the middle of the circle. This is called the center point. Okay, so the dot in the middle is called the center of the circle, which you've probably already heard of. Now, very important, if you have a line that is going from the center of your circle to the edge of your circle, this length right here is called the radius of your circle. Okay, from the center to the edge is the radius of your circle. If you have a line going through the center of your circle, going from the edge to the edge of the circle, this is called a diameter. Okay, so radius is from the middle to the edge, all the way across from side to side through the center is called the diameter. Okay, two very important words we'll be using quite a lot in this topic, so please get these drawn down for me, radius and diameter. Okay, up next we have a line. If it goes from the edge to the edge of the circle, but it doesn't go through the center, so it's not a diameter, this line right here is called a chord. Okay, it's a chord. What this chord does is it splits our circle into two parts. We've got a part right here and a bigger part right here. These two parts are called segments of the circle. Okay, this part right here is going to be a minor segment because it's less than half of a circle. This section over here is called a major segment. Okay, so the line is called a chord and the parts of the circles are called segments. Up next, another way we can cut up a circle is we can cut it like a pizza slice. Okay, so two radii from the center, creating a section of the circle, which is called a sector. Once again, if we wanted, we could have said this is a minor sector and the rest of it would be a major sector, but it's the same concept. Okay, so a pizza slice is called a sector. Okay, up next we have a line. So we said a line going from edge to edge, not through the center, is called a chord, which is true if that line keeps going beyond the circle, so it hits both edges and then keeps going. This line is actually called a secant. Okay, so it's a chord that just keeps going on forever. So that's called a secant. Now, if this line is not passing through the circle twice, if it's only touching the circle in one spot, like this, that's what we call a tangent. Okay, so a lot of new words I'm guessing you've not heard of before. So a secant is a line passing through a circle. A line touching a circle is called a tangent. Okay, and last bit of terminology, we have the distance around the outside of the circle. So if we were going to measure how far around this circle it is, that would be called the circumference length. Okay, so the outside of a circle, from now on, we're going to be calling it the circumference of the circle. And if you have just a piece of your circumference, so you have like a section of your outer shell, we call this an arc of the circle. Okay, so the whole thing's called a circumference, a little piece is called an arc. And there we go, there's all the words we're going to use throughout this topic. We're going to talk more about circumference now. We're going to sort of do an investigation on how we would find the length of a circumference. So I've got three circles for you here. A small blue one with a diameter of 2 centimeters, a medium-sized green one with a 4 centimeter diameter, and we've got a 6 centimeter diameter for the larger circle. Now, the way you could measure the outside of these circles is you could cut a bit of string and see how much string goes around the edge, and then lay that string flat on a ruler and see how far around the outside it is. So I did that with these three circles. I tried to be pretty accurate. And for this one, I got a distance around the edge, a circumference of approximately 6.3. So this squiggly equal sign, it means approximately equal to. It means I've done a bit of rounding off. So roughly 6.3 centimeters around the outside. For the green one, I measured the outside and it was about 12.5 centimeters. Okay, and for the large red one, the circumference length around the outside of the circle, I calculated with some string to be about 18.85 centimeters. So I was really accurate with that one. Okay, so after this, I wanted to see if there was some sort of number or some sort of relationship or pattern between the length of the diameter of a circle and the distance around the outside, which is the circumference. So I'm trying to see if there's some number that I can multiply 2 by that gets me an answer of 6.3. So to figure that out, I worked backwards and I did a division. I did 6.3 divided by 2. I got an answer of 3.15. Okay, so 2 multiplied by 3.15 gets me 6.3. I did that again for the green one. I did my 12.5, my circumference. I divided that by 4. It got me an answer of about 3.13, so pretty similar to the first answer, 3.15. I repeated this once more for the red circle for our circumference. I did 18.85. I divided it by the diameter of 6, and it gave me about 3.14. So what I'm noticing each time is that when I do my circumference divided by my diameter, I always get an answer around 3.14. Okay. What we're seeing here is a special mathematical constant that we've known about for a few thousand years, which is called pi. Okay, so anytime you take a circle's circumference and you divide it by its diameter, you always get the same number. It's called pi, and it's 3.14159265. And those decimal places go on forever. This is a never-ending decimal number. It's called an irrational number. The symbol that we use to represent pi in mathematics is this Greek letter just here. This is the symbol for pi. So from now on, when I write this symbol here, what I really mean is the number 3.1415 and so on. Okay, so why this number is so important is because, as we just saw, pi is the number of times that the diameter of a circle is going to fit around the outside of the circle. So this blue line could fit along this blue circumference line exactly 3.1415, etc. times. And that's how we calculate our circumference. So our circumference length is always going to be our diameter multiplied by pi. Okay, so pi is a number that's going to be programmed into our calculators. We don't have to memorize it, of course, because our calculators or our phones can do that for us. So there's our formula we're going to be using today to calculate the distance around the outside of a circle, diameter times pi. So if you have a scientific calculator with you, the ones we use at our school have the pi above this bottom number down here. Might be a bit hard to see on your screen, but above this times 10 to the x is a yellow little pi symbol. Anything that's in yellow, it means you have to press shift first to get there. So to get pi on our standard calculators, you press shift and then you press this number here and you'll get pi. If you don't have access to one of these because you're at home without a calculator, that's all good, because if you turn your phone sideways, they're all programmed with a pi button. For the iPhone, it's just here. So if you press that button, your phone or your calculator knows that what you really want is 3.14159265, blah, 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 blah. Okay? So let's have a go at using this formula to find the circumference length of these two circles. So in the first one, we have a diameter of 8 meters. We want to find the circumference. Okay, so like we saw, all you need to do is take your diameter and multiply it by pi, and that gets you your circumference. So for question A, we're going to do 8 multiplied by pi. So if we press pi in our calculator and then times by 8, it should give us an answer, a decimal answer, around 25.1 meters. Again, I'm writing the squiggly equal sign because that means that we're doing some rounding. It means approximately equal to. Okay, so please double check that if you've got a phone or a calculator at home, you can type in pi times 8 and get an answer of about 25.1 with some more decimal places. Okay, for question B, we are not going to do pi times 10 because 10 is not the diameter of this circle. 10 is the radius. So the radius is from the center to the edge. We want the diameter, which is twice the length of the radius. So if we double this radius, we would get a diameter of 20 millimeters. That's the number we need to multiply by pi, not the 10. Okay, so we're going to do circumference equals pi times diameter. So we're going to do, once again, this time it's going to be pi times 20. We'll get our phones or our calculators and we'll type that in. We should be seeing an answer of around 62.8 millimeters. So there we go. To find your circumference, it's just pi times diameter. Super, super simple. Okay, up next, this is a bit of a memory test from the earlier part of the video where we were looking at the different parts of a circle. I want you to see if you can remember what any of these 8 labeled objects are. So we've got A here, we've got a B right here, we've got a pizza slice for C, D is this section right here, E is this line here, we've got F here, G around the outside, and then H here. Pause the video and see how many you can remember already. Okay, for our first one, A is across the width of the circle through the center. So A is called a diameter, as we've been using many times already. B is a section that's made by a chord. So this section is called a segment. If you're being really sort of more accurate, you could have said minor segment, but just segment is fine. C is a pizza slice. That's what we called a sector before. So a pizza slice is called a sector. And D, we said that a part of the circumference, so a part of the outside, is called the arc. So it's an arc of a circle. Over on the right, we've got E from the center to the edge. That's called the radius of the circle. So E is a radius. F is a line from edge to edge, but not through the center. So F is what we call a chord. We've got G up next. So G is the distance around the outside. That's what we call the circumference of the circle. And H is a line that passes through the circle in one spot. And if you remember, that's what we called a tangent. So well done if you got some of those. If you got 8 out of 8, you're doing really well. So congratulations. Okay, up next, we've got a more challenging question than the circles we were working with before. We have find the perimeter of this figure, and we're going to answer to the nearest whole number. So hopefully you remember from our earlier lessons in the year that when we're asked to find the perimeter of a shape, we're trying to find the outside. So we've taken a circle and we've cut it in half, and this shape is called a semicircle. If you want to challenge yourself, you can pause the video and see how you would have a go at finding the outside distance of this figure. Okay, so let's have a go. So to find the perimeter, of a semicircle, we've got to keep in mind we've got two pieces here. We've got a line here that's 10 centimeters long, and we've got a curved part, which is half of a circumference. So to answer this, we need to figure out how we would find the circumference of this circle, and then we're going to cut that in half, and we're going to add 10. Okay, so normally if this was an entire circle, the distance around the outside would be 10 times pi. If we want just the top half, we just need to divide it by 2 or multiply it by a half. So first thing we're going to do is pi times diameter. That would get us the circumference. We're going to divide it by 2, so we just get the top half of the circle. So pi times 10 divided by 2 works out to be around 15.7. So there's your half circumference. Now, because we're finding the perimeter, we also need to add on the 10, and then we've got the entire shape enclosed. So all we've got to do is take our number here, our 15.7. We're going to add 10, and the question asked us to leave it to the nearest whole number. So this calculation will get us 25.7. So we'll round it up to 26 to the nearest centimeter. Okay, so to find part of the circumference, if it's a half circle, you want to cut it in half. If it was a quarter circle, you'd want to divide it by 4, so on and so forth. Okay, that leads us to the end of this video. As a finishing challenge, if anyone thought that last challenge question was nice and easy, this one's a bit tougher. It's a COMTEST. This is a challenge for people who want to have a go and leave their answers in the comments below. First correct comment will get a prize. The question is, find the perimeter of this figure to the nearest whole number. Think you know what you're doing? Have a go and let me hear your guesses down below. Okay, thanks so much for watching this video. I hope you learned something. For my class, there will be some practice questions up on Google Classroom for you to have a go at. Let me know if you need any more help, and thank you for watching.